Let's graph another exponential function. This one is f of x is equal to 2 raised to the negative x plus 1. So in our xy table, we want to try and find some good numbers so we get a nice graph. So we're going to look here at the exponent to see what this would be 0. And if I put in a negative 1, then this value for the exponent would be 0. I'll go a little smaller, negative 2, negative 3, and a little larger, 0 and 1. These numbers are going to go back into the original equation. So we'll first put in negative 3, and negative 3 plus 1 is negative 2, and then I want the opposite of negative 2, and that would be positive 2. And 2 raised to the positive 2 power is 4. So the next number on our list is negative 2. So negative 2 plus 1 is negative 1, and the opposite of negative 1 is positive 1, and 2 raised to the positive 1 power is 2. Putting in negative 1 in the original problem, negative 1 plus 1 is 0, yay, and the opposite of 0 is 0, yay, and 2 to the 0 is 1. The next number on our list is 0. So 0 plus 1 is 1. The opposite of 1 is negative 1. And that's an exponent. And a negative exponent is a reciprocal. So that would be 1 over 2 to the 1 power, or 1/2. Next, number 1, that goes back into the original equation. 1 plus 1 is 2, but there's a negative outside that. So that's 2 raised to the negative 2 power. When you have a negative exponent, that means you have a reciprocal. That's 1 over 2 squared. And 2 squared again is 4, so that's 1/4. Plotting these points at negative 3, positive 4, and negative 2, positive 2, and negative 1, 1, 0, 1/2, 1, 1/4, and as you can tell now we're getting smaller and smaller. So our exponential graph is decreasing once again, and we need to put in some information. 1, arrows to indicate that it's going to continue, and an asymptote so everyone knows that it won't go any lower than the x-axis. And again, why isn't it going any lower than the x-axis? It's because there's no number added outside of the exponent. So you could add 0 and not change the problem, and that's where our asymptote is. Domain is all real numbers. And range, well, it goes really high, but we start with our low number first, and it doesn't quite get to 0. So our range is open parenthesis 0, comma, infinity, end of parenthesis.